Now, another two important definitions, that what do we understand by this moment of inertia? Moment of inertia. Okay. Another definition, that is called as radius of gyration. Another important definition, that is called as radius of gyration. Sometimes both the definitions asked for 2 marks. Sometimes only one definition, that what is moment of inertia. Sometimes what is radius of gyration. Sometimes what are the dimensions of moment of inertia and its units. What are the dimensions of radius of gyration and its units. So let us consider the first one, that what is moment of inertia. Moment of inertia, it is the product of it is the product of mass and square of its distance. What do we understand by moment of inertia? Moment of inertia, it is the product of mass and square of its distance. It is denoted by the factor I. Okay, so mathematically we can be written it as, mathematically we can write, that is I is equal to the product of mass square of distance, that is I is equal to mr square. Okay, units, m with the mass, it is measured in kilogram. R with the distance, it is measured in meter. R square, so kilogram meter square. This is the unit in SI system, or we can say this is the system that is measured in MKS or MKS system. Gram centimeter square, it is in CGS system. Okay, now what are its dimensions? If we write about the dimension, that is in the term of MLT. M stands for mass. Yes, mass is there. The power of mass is 1. R square, that is the distance, and it is written in the form of L. So L square. No information about the time, so the power of T is 0. So what do we understand by moment of inertia? It is the product of mass and square of its distance. Generally denoted by the factor I, mathematically can be written as I is equal to, yes, I is equal to mr square. Its units kilogram meter square in MK system, gram centimeter square in CJ system, and its dimensions are m raised to 1, L raised to 2, T raised to 0. Now, what do we understand by the term radius of gyration? Radius of gyration, it is the distance. It is the distance from axis of rotation. It is the distance from axis of rotation and the point at which whole mass of a body and the point at which whole mass of a body can be supposed to be concentrated. What do we understand by radius of gyration? It is the distance from axis of rotation and the point at which the whole mass of a body can be supposed to be concentrated. Okay, it is written as it is written as that by the formula, that is I is equal to mk square. It is written by the formula I is equal to mk square, where k be the constant factor. K be the constant factor. It is called as a radius of gyration. What do we understand by k? K be the constant factor. It is called as radius of gyration. Written as in the form of k. We are writing in the form of k. That is k square is equal to I upon m. Okay. Or k is equal to under root I by m. This is the general formula for radius of gyration. Now, what do we understand by its units? Now its units. Radius of gyration, it is measured in meter in mk system. Okay, and centimeter in CGS system. What are its dimensions? If we are writing about the dimension, we know that dimension generally expressed in the form of MLT. Okay, the power of mass, it is 0. Okay, length for radius, the power of length is 1, and no information about the time, so the power of t is 0. So what do we understand by radius of gyration? It is the distance from the axis of rotation and the point at which whole mass of a body can be supposed to be concentrated. Generally written as I is equal to mk square. Okay, if we are writing in the form of k, where k be the constant of proportionality called as radius of gyration. So k square is equal to I by m, or k is equal to under root I by m. Units are meter in MK system, centimeter in CJ system. It has a dimension m raised to 0, l raised to 1, t raised to 0. Once again, I am reminding you that if it is asked for 2 marks, the question will be define moment of inertia and radius of gyration. In this way, for 2 marks. If for 1 mark, what is moment of inertia? For 1 mark, what is radius of gyration? Sometimes, what are their units and dimensions? Okay, so watch it first. Now, after that, another article that carries 2 marks, that derive an expression for kinetic energy of a rolling body. Number of times the question is asked that what do we understand by the expression for kinetic energy of a rolling body. A rolling body, it is said that whenever a body rolls, then at that time, what happens, listen carefully, that whenever a body rolls, just let us consider the following diagram. This is the sphere, okay, and here the sphere is represented as in the rolling form. It is said that here the sphere is a rolling, that is nothing but the rolling body. What we are observing in the diagram, that what is said, whenever a body rolls, then it performs two types of kinetic energy. One is called as translational kinetic energy, and the other one is called as rotational kinetic energy. What is said here, that whenever a body rolls, what happens? The body performs two types of kinetic energy. One is translational kinetic energy, and the another one is called as rotational kinetic energy. So, the total kinetic energy can be written as So the total kinetic energy, that is capital E, is equal to, okay, kinetic energy, the first one, that is related to translational, plus another kinetic energy, and it is related to rotational. Okay, mathematically total kinetic energy, that is E, is equal to translational kinetic energy plus rotational kinetic energy, or E is equal to, yes, we are well familiar about the translational kinetic energy, that is nothing but one half mv square, that is called as translational kinetic energy, plus what do we understand by rotational kinetic energy? The general formula for rotational kinetic energy is 1/2 I omega square. Okay, where m be the mass, v be the velocity of a body, I be the moment of inertia, and omega is nothing but the angular velocity. Now what do we understand by here? What do we understand by moment of inertia I? What is moment of inertia? It is the product of mass and square of its distance. Product of mass and square of its distance. That is I is equal to mr square. Also, we are well familiar about the relation between linear velocity and angular velocity, that is v is equal to r omega. You can write r in the form of capital R, in the form of small letter also. V is equal to r omega. Just omega is there, so what omega becomes? Omega is equal to v by r. So in this way we have two values, first of I, another of omega square. So just put the values here. What we get? That is total kinetic energy, that is E is equal to 1/2 mv square, it is as it is, plus 1/2, yes, what do we understand by I? I is equal to mr square, the product of mass square of distance. Another information about the I, that is called as I is equal to mk square, related to the definition of radius of gyration. What do we understand by I? I be the moment of inertia, nothing but the product of mass and square of distance. Another formula of I related to radius of gyration, that is I is equal to mk square. Just put the value of I, that is mk square. Okay, what about omega? Omega is nothing but v by r, but omega square is there, we can write v square upon r square. Okay, watch it carefully, that is E is equal to, here 1/2 mv square, also 1/2 mv square is there, so take 1/2 mv square common, 1/2 mv square, this we are taking common. Now nothing is there, 1 plus as it is, which factor we have, constant we have taken here, 1/2 mv square, what remains here, k square upon r square. That's all. This is the general formula for kinetic energy of a rolling body. What we can write here, this is the general formula. This is the general formula for kinetic energy of a rolling body. Okay, how to remember it? Whenever a body rolls, it performs two types of kinetic energy. One is translational, another is rotational. So total kinetic energy, that is the sum of translational plus rotational. We are well familiar about translational, 1/2 mv square, about rotational, 1/2 I omega square. Put the value of I, mk square, put the value of omega, v by r. We have in this way. Take the common factor, 1/2 mv square, what remains? 1. So 1 plus k square by r square. The general formula for kinetic energy of a rolling body. Okay, watch it. We have the question that what are fluids? Write its properties. Simplest way, fluids are the substances. What do we understand by fluids? Fluids are the substances which can flow. Okay, what do we understand by fluid? Fluids are the substances which can flow, the simple way. Now, what do we understand by its properties? The simplest way we are dealing with fluids. Okay, first we have write its a definition that fluids are the substances which can flow. The very first property that from the definition itself, fluids can flow. First property from the definition, fluids can flow. Okay, it is said that second point, fluids have the ability. Fluids have the ability to take the shape of container. The most important point, fluids have the ability to take the shape of container. Third point, it is said that fluids does not oppose fluids does not oppose the deformation. It is another important point about the fluid that they does not oppose the deformation. It means what we say, it means they can be it means they can be permanently they can be permanently deformed. It means they can be permanently deformed. Why? Because they does not oppose the deformation. It means they can be permanently deformed. Another important point is that the flow of fluid is the flow of fluid is irrotational. What do we understand by another important point, that the flow of fluid is irrotational. Okay, again extra point, it is incompressible. Okay, it is incompressible. First, they have ability to flow. Second point, fluids have the ability to take the shape of any container. Third point, fluids they does not oppose the deformation. It means they can be permanently deformed. Number 4 point, the flow of liquid is irrotational, and another important point is that it is incompressible. Okay, so watch it, carries 2 marks. Now let us consider that what do we understand by the term cohesive forces. What are cohesive forces and what are adhesive forces? First of all, what do we understand by cohesive force? Okay, cohesive force, the force of attraction, the force of attraction between the molecules of same kind. Try to get the meaning of the sentence. Where the attraction takes place, here the force of attraction takes place in between the molecules of same kind. Whenever force of attraction takes place between the molecules of same kind, then it is called as cohesive forces. So what do we understand by cohesive forces? The force of attraction between the molecules of same kind is called as, yes, it is called as cohesive force or cohesive forces. Now, what do we understand by the term adhesive forces. That what do we understand by adhesive forces? Adhesive force, here D is there. D stands for, generally D stands for different. Cohesive, S for same. How to remember it? Cohesive force, in cohesive force S is there. That is the force of attraction between the molecules of same kind. Adhesive, D stands for different. So what we can say? It is the force of attraction. The force of attraction between the molecules of different kind, between the molecules of different kind, is called as, yes, it is called as adhesive force. Okay, what do we understand by this? It is asked at a time in the board HSC exam number of times for 2 marks, that what are cohesive force and adhesive force. S stands for the force of attraction between the molecules of same kind. D stands for different. The force of attraction between the molecules of different kind is called as adhesive force. Okay, now what do we understand by the term molecular range? Okay, what do we understand by the term molecular range? Molecular range, the distance up to which one molecule, the distance up to which one molecule can attract to another molecule. What do we understand by molecular range? It is the distance at which one molecule can attract to another molecule is called as, yes, it is called as molecular range. Okay, molecular range, it is the distance up to which one molecule can attract to another molecule, then it is called as molecular range. Another important point, that what do we understand by the term sphere of influence? What do we understand by the term sphere of influence? Okay, if we are drawing the sphere, let us see, just to understand the concept of sphere of influence. To draw the sphere, generally we choose a point O. That O is acts like a center. Okay, so how this sphere drawn? The sphere drawn by a molecule. The sphere drawn by this molecule. What this molecule, this point O acts, the point O acts like a sphere, or it acts like center of a sphere. Okay, this sphere we have draw here. How this sphere we have draw? It is just with the help of this point O. What the point O acts? Here the point O acts like a center. So what we can write about the sphere of influence? Sphere of influence, the sphere drawn by a molecule. The sphere drawn by a molecule. Yes, what this molecule O acts as a center. Okay, as a center. And what this point R is called as radius. Okay, the sphere drawn by a molecule as a center, and radius equal to molecular range is called as, yes, it is called as sphere of influence. What we understand by sphere of influence? To understand the concept of sphere of influence, just we have draw the diagram here. We have draw the sphere. This O acts like the center. Okay, from center to point P, the distance is called as radius. Okay, so what is here? Sphere of influence. Sphere of influence, the sphere drawn by a molecule as a center and radius equal to molecular range, it is called as sphere of influence. Okay, watch it. Let us consider the important article generally for 2 marks, that what do we understand by the term capillarity. Okay, what is capillarity? It is asked for 2 marks for number of times. Explain capillarity in this way. Capillarity, let us consider capillary tube you already used in the chemistry lab, that is called as capillary tube. Okay, that we are well familiar. Capillary tube is a tube having a very small bore. Okay, what do we understand by capillary tube? It is a tube having a very small bore, that is called as capillary tube. To understand the concept of capillarity, let us consider a beaker. Okay, let us consider a beaker which contains water. To understand the concept of capillarity, take a beaker. Okay, take a beaker which contains water and dip the capillary tube in the beaker. What happens? Obviously, the water rises in a capillary tube. Okay, obviously the water rises in a capillary tube. Here, see the position of the water. It is seems to be U-shaped. Here, this, what is this? This is nothing but the capillary tube. This is nothing but the capillary tube. Whenever we dip the capillary tube in the beaker contains water, what happens? Water rises in a capillary tube. Okay, the first case, right? We will write these things, that the first important point, take a beaker, okay, contains water. Take a beaker, contains water, dip the capillary tube, dip the capillary tube in the beaker, dip the capillary tube in the beaker. Just we have seen what happens. Water rises in a capillary tube. Try to get the meaning of the sentence. What we have written here: take a beaker, contains water, dip the capillary tube in the beaker. What happens? Water rises in a capillary tube. Let us consider another beaker. Which contains some mercury. Again dip the capillary tube in the beaker which contains mercury. What happens? Here, see the position of the mercury. Here, mercury does not rises. Watch the diagram. What is shown in the diagram? Take another beaker. Contains mercury, comma, dip the capillary tube in the beaker Yes, what happens here in the beaker? What happens? Mercury. Mercury does not rises. Mercury does not rises. It it falls down. What we have written in the first para, take a beaker contains water, dip the capillary tube in the beaker. What happens? Water rises in a capillary tube. Take another beaker which contains mercury, dip the capillary tube in the beaker, contains mercury. What happens? Mercury does not rises, it falls down, comma, inverted comma. Yes, this process of rising or falling of a liquid, this process of rising or falling of a liquid in a capillary tube, in a capillary tube is called as, yes, it is called as capillarity. Okay, carries 2 marks. Watch it carefully.